everyone, this is Mrs. Vanette, and you have reached Regents Physics. Target audience for this is grades 11 and 12, and Regents Physics indicates that this is for New York State, meeting New York State standards. The lesson we have planned for you today, Part B, special cases of 1D motion free fall. The agenda for this lesson, there will be free fall notes, which follows direct instruction. Part 2, free fall example, which is guided practice. And Part 3, whiteboard problems, which will be our check for understanding. Objectives being reached in this lesson. Number 1, understand how gravity affects motion. And number 2, use algebra to solve equations relating to vertical D1 motion. So for our special case, free fall, we will be understanding how gravity affects motion. All objectives will be located at the top of each slide, so you can check back to make sure you are meeting those objectives. Free fall, definition. Acceleration due to gravity is the acceleration of an object in free fall that results from the influence of the Earth's force of gravity. Acceleration is a vector quantity, therefore, we have both magnitude and direction. Acceleration due to gravity equals 9.81 meters per second squared towards the center of Earth. You can find these in your reference tables. However, we know that acceleration is a vector quantity. Therefore, if it is towards the center of the Earth, we're going to call this down, and it's going to have a negative sign. If we neglect air resistance, all objects fall with the same acceleration, regardless of its mass. So what does this look like in the real world? We have a person standing on the cliff, and a reminder, acceleration due to gravity equals 9.81 meters per second the entire fall. So at the top, we assume that the person is still holding on to their object. T equals 0 seconds, and there is no motion yet, so velocity equals 0 meters per second. After the object starts to fall freely, at 1 second, velocity will then equal 9.81 meters per second. It will continue falling, and at 2 seconds, velocity will then equal 19.6 meters per second. At 3 seconds, velocity will equal 29.4 meters per second. At 4 seconds, velocity will equal 39.2 meters per second. And then at 5 seconds, velocity will equal 49.1 meters per second. Did you see a pattern here? At this time, you can pause this video, go to your Google Classroom, follow these links to see this phenomenon in action. Moving on to Objective 2, use algebra to solve equations relating to vertical D1 motion. We have this example. Remember, during any physics problem, we should be using the guess method. G stands for writing down all givens. U stands for writing down the unknown. E stands for writing down an equation. The first S stands for substituting in your knowns. And then the second S stands for solve for your unknown. So our question asks, a man pushes a huge boulder off a cliff 50 meters high. Part A, what is the boulder's velocity when it hits the ground? Part B, when does the boulder hit the ground? Go ahead and pause now. Take your time, go through the guess method, and don't forget to draw a picture. Here's our answer to our example. Did you get it right? If not, let's go back and try again. Since you have mastered our example, go ahead and perform these whiteboard problems on your own. A ball is dropped from the top of a building and lands 1.25 seconds later. Part A, how tall was the building? And part B, what is the speed of the ball right before it hits the ground? Go ahead and pause, take your time, make sure to draw a picture and go through the guess method, then check your answers. Posted are our answers to this whiteboard problem. If you need a detailed solution, go ahead, sign on to Google Classroom, and check for detailed solutions. If you need more explanation, you can rewatch this video or ask Mrs. Vanette in class for extra help.